Hey everyone, this is Dan Lattiser, coming to you with Chem-125 through Doane University online for the Module 1 Advanced Concepts presentation on using salt, pepper, and balloons to observe the reaction between the static electricity and its relationship with the table salt and the pepper. This is my current setup here. You have your Morton salt, black pepper ground. I pre-ground it so that it's ready to go. And I have two different balloons in case one of them pops, and also for the demonstration of control. I have my lab assistant Rango and my lab assistant Finn. They're both being really great. So the idea of the assignment is to conduct this little experiment, find out if the salt and the pepper both react to the negative charge of the balloon after it has, after the friction has been applied, creating a negative charge. So we will do as instructed, which is we'll lay out, there's our pepper. I didn't have any finely ground pepper, but this should make for a good contrast, a little bit bulkier. So it should be very clear to see. Add about equal part of salt, maybe a little bit more. Just using a little chopstick to mix it up. And then I'll shake it around, try to get it more evenly distributed. All right, that's our mixture. I chose the color of the plate just to have a better color contrast, as well as the color of the balloons. I'll go with the pink one because that probably has just a little bit better contrast to it. The speculation from the assignment is that the pepper will be attracted to the negative charge, meaning that it must possess a positive charge, and that positive charge will be attracted to the negative charge, and it will ascend or levitate towards the balloon, and that the salt will remain in place. So we shall see if that is true. Lab assistant Rango for some static electricity. Good boy. All right, here we go. All right, and just as advertised, we got a lot of ground pepper and zero salt. And even when you tap some of it as it's about to fall, some of it comes back to the balloon. As my little control, this is, I guess, an additional part of the experiment. Obviously, this balloon's been handled, so it may possess some slight negative charge to it, but I have not rubbed it on my dog's head, and this will most likely produce zero reaction or a very, very minor reaction in comparison to what was previously observed. And we will go ahead, no static, no rubbing of the dog's head. And nothing. So that was our little control. We'll no, don't bite it. Don't bite it. And then we'll go ahead and add that back in, and minor reaction. There we go. This will be good. And Finley for the win. She's got good static electricity conductor. All right. Speculations for this assignment would be that, as I recall, there are 11 or 12 protons in salt, and that it is balanced with 11 or 12 electrons, and that it, due to it being balanced, either does not allow for it to, because of those bonds, it doesn't allow for the negative charge of the balloons to initiate a reaction, or it has a density that is much more significant than that of the pepper, and the pepper being positive, obviously causing that the reaction where it's drawn to the negative charge to the balloon, but it also may have a significantly less mass, and therefore the amount of static electricity is strong enough to get that reaction. Those are my my two, I guess, little postulates on why we observed what we observed. So yeah, that's the experiment for today. And if I can get this into a PowerPoint, I will try to attach some visuals if that's possible. Thank you for watching, and I hope you guys all have a wonderful weekend. All right, guys. Dan Ladd signing off. Finn and Rango signing off. See you guys.